we're going to talk about how we use row operations to find an inverse. And the reason that you'd ever want to do this is if you ever were bigger than a 2 by 2, matrix multiplication just becomes really tricky because you have to multiply 3 rows by 3 columns and then add those together and keep track of all of that, and then you've got 9 equations to solve. So what we're going to show you is how to use row operations instead. So suppose that A is equal to the matrix 4, 3, 1, 0. Remember, this is actually the exact same problem we did in the last one, but we're going to show it a different way. So what we're going to do is we're going to first create an augmented matrix. So what we're going to do is we're going to take our 4, 3, 1, 0, and we're going to augment this with the identity matrix 1, 0, 0, 1. If this were 3 by 3, we go 1, 0, 0, 0, 1, 0, and 0, 0, 1. Now we're going to do our row operations. So let's use Gaussian elimination. That's what we're going to say. Use Gaussian elimination. So this is going to take a little bit more room and more work. But the first thing I'm going to do is I'm going to swap row 1 with row 2. So now we get 1, 0, 0, 1, 4, 3, 1, 0. Notice I swapped the entire row, even the augmented pieces. Then we're going to take row 2 minus 4 row 1 and store that in row 2. So it's going to be a minus 4, a 0, and a minus 4. Well, that gives me 1, 0, 0, 1, 0, 3, 1, minus 4. Now we take row 2, and multiply it by a third and store that in row 2. That'll put a 1 right here. 1, 0, 0, 1, 0, 1, 1/3 minus 4/3. And my last step would normally be to put a 0 right here, but there already is one. So there's nothing else we need to do. This is done. So step 3 is to grab the inverse, which is the old augmented matrix. So my inverse is 0, 1, 1/3 minus 4/3. And now we can use what we've learned from Gaussian elimination to find inverses of larger matrices. For the 2 and 2, it ends up being roughly the same as which one you prefer doing. But as it gets bigger, using Gauss-Jordan elimination becomes much more important.